Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: the world's first diamond semiconductor mass production facility has been completed in Okuma, Fukushima Prefecture, Japan. Let's break down what this really means. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of it this way: a legendary workshop for crafting mythical weapons has finally been built, but the tools aren't inside yet. So sit back and enjoy. If I had to sum up today's news in one sentence, the workshop for forging the legendary metal orichalcum has finally been completed. But, and this is important, what's been completed is the building itself. The machines that go inside are still being installed. In fantasy stories, there's a legendary metal called orichalcum. It's far harder and stronger than ordinary iron, surpassing any weapon or armor ever made. But there's a huge difference between legendary and amazing and actually manufacturable at scale. That gap is exactly what we're talking about today. The news is that the building for mass producing this orichalcum has been completed. The manufacturing equipment moves in during fiscal year 2027, and full production is planned for fiscal year 2028. In other words, the forge is not yet running. So why is everyone paying attention now? Because orders from the heroes who need to save the world are already coming in. These are heroes heading into extreme environments. Think the castle of a final boss, filled with flames and curses, where ordinary swords simply shatter. Those heroes have already said, if you can make it, we'll buy it. This material isn't better than ordinary materials. Its value lies in the fact that it can work where ordinary materials simply cannot. That's the essential point. From here, I'll explain how this fantasy analogy plays out in real industrial terms. Let me summarize the orichalcum forge stance. A legendary building has been completed, orders are waiting, but the smiths and their tools haven't arrived yet. The forge is real, the weapons are not yet. And honestly, my current assessment of diamond semiconductors is almost exactly the same as this orichalcum story. Today's news is about a company called Okuma Diamond Device, completing what they are calling the world's first diamond semiconductor mass production facility in Okuma, Fukushima. The completion ceremony was held on May 29th. What makes diamond so remarkable? It excels under three extreme conditions: high temperature, high radiation, and high power output. Silicon typically hits its operational limit around 150 to 200 degrees Celsius. Diamond, in theory, can operate above 500 degrees Celsius. It's also highly radiation resistant, making it well suited for use in space and nuclear facilities. However, and I want to emphasize this from my own years on the factory floor, there is an enormous wall between having superior material properties and actually being able to mass-produce semiconductor devices. Silicon took decades of research, development, and capital investment, starting in the 1950s, to reach today's production capabilities. Diamond is now at the stage of trying to climb that same wall. Reports are calling this the world's first mass production facility, but what I find myself looking for are the concrete numbers, which I haven't seen yet. What's the wafer size? What's the monthly production capacity? What's the device yield? All three numbers need to be real before the word mass production means anything. At this stage, the accurate description is not a mass production facility has started operating, but rather the building that will house a mass production facility has been completed. Equipment installation is slated for fiscal 2027 and full operation for fiscal 2028. Meaning actual device production is still more than 2 years away. That said, there's a compelling reason why this is worth watching. Specific customers are already in the picture. The decommissioning of the Fukushima Daiichi nuclear power plant requires analyzing, evaluating, and removing fuel debris, melted nuclear fuel. The radiation levels in that environment are extreme, and conventional semiconductor sensors fail quickly. Diamond semiconductors have real potential here. Space is another use case being discussed. Space is a harsh environment, intense radiation and extreme temperature swings. Radiation-hardened semiconductors are already used in space applications today, and diamond is a serious candidate for the next generation. That said, the market size remains small, and whether it translates into volume production depends on what happens next. Looking at semiconductor history, every new material needs a first success story to break into volume production. Silicon started with the transistor. Silicon carbide, SiC, expanded into mass production through inverter diodes for electric vehicles and trains. Diamond will likely follow the same path, building a track record with the simplest devices first, starting with diodes. SiC saw explosive production growth once it was adopted in EV and railway inverters. For diamond to follow that path, the key is finding a market where diamond is not just better, but irreplaceable. Whether decommissioning or space becomes that market, I'll be watching closely once operations begin in 2028 and beyond. The choice of Okuma Town deserves mention. Okuma is the municipality where the Fukushima Daiichi nuclear power plant is located, a town that was partially designated as a difficult-to-return zone following the 2011 accident and is now in the process of recovery. Building a diamond semiconductor facility there creates a geographic and industrial connection to decommissioning technology and makes this a story about regional industrial revival as well. Let me recap today's news. Okuma Diamond Device has completed a factory building in Okuma, Fukushima. Diamond semiconductors are a next-generation material with exceptional tolerance for high temperatures, high radiation, and high power output. But realizing mass production will require concrete answers on wafer size, monthly output, and yield. Equipment installation is planned for fiscal 2027, full operation for fiscal 2028. Decommissioning and space are the target applications, and the realistic path is building a production track record starting with diodes. My personal take. Many of you are probably thinking, how many times have we heard about a diamond semiconductor boom? The research history spans decades, but this time a facility building has actually been completed. That is real progress. Still, tempered expectations are in order. Meaningful mass production won't happen until 2028 at the earliest, and even then it will start with a very small, very specialized set of applications. Silicon and SiC walk the same road. Let's stay patient, but keep our eyes open. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.